So this is the turbo version of the Sunburn monitor timer UV alarm system package. I'm just going to do this in double quick time. Feel free to use the pause button if you want to replicate it along. So the first instance, we are going to grab a on button A pressed, and then we are going to show a number, and we're going to go to the input block and get light level. The PDF is in color, and I would remind you that the colors of the blocks all match up with the different blocky sections. So at this point the student can then compile and download that and then get a sense of what the readings are that come from the LEDs. So that covers point 1 and point 2. I would refer you to the other tutorials if you need help on copying it over to the onto the microbit. So the next section is where we are going to actually capture the value. So we're going to set a variable to the light level, and we are going to call that something appropriate. I shall try to resist my normal bizarre names. I'm going to call this light reading to the light level. It's good practice to store these things in variables, because if we then show number variables light reading, and then but if we actually have the light level in there, we might actually have something different from when we get to the next step, which is show an appropriate message. So if we need some logic, and then we need the variable light reading. Now the light reading from the LEDs will go up to a maximum of 255, so we'll say if it's greater than, say, 175. As ever, I've used the wrong keypad when recording this, and if that's a problem, we can then show a string, and we will just get it to put H, which is rather handy because then it doesn't scroll. And that gets them to the next point. However, this is going to happen so quickly that they're not going to see much, so it's actually quite useful to pause that. The light reading will scroll, but just sort of give it time to get on through there. Now, if the student is a master coder or has got to this point, she can add in an else if, and if she's really switched on the else, we just click the wheel again. We can duplicate this block, although they are entirely, it says we'll duplicate this block, entirely within their right to, I'll just throw that away now. We seem to have blocks all over the place, right? So we can say that, right, okay, spot the deliberate mistake, that should have been greater than, and that will be less than, and we will make that 50, and we will say that that is the low reading, and we will duplicate that and say that's the mid-range reading. So we capture the light level, we show it, we wait just a second, well, tenth of a second. If it's greater than 175, we show high. If it's less than 50, we show low, otherwise we show a dash. But as I say, the sort of more student that's just getting to grips with programming will just get this if and show string. This else if and else is entirely optional. So the next step is to hand out the external sensors, the light dependent resistors, and rather than using set light reading to light level, we'll take that away now, because we're no longer using the LEDs that are on the microbit, and we will use the pins analog read, and if they have put the crocodile clip onto 0 and the red one onto 3 volts and the black one onto ground, they will then be instantly in business. However, these values will now no longer be true, because typically a bright value for the LDR will be somewhere over 600, and a low value will be, say, 100, and the middle is in the middle. And obviously they can go through the same calibration exercise of making note of various different things and finding out what the word ambient means and the like. The next step then is to add in the buzzer. If you are using torches, this is a good time to take them away, because after this they don't have to get an extreme reading. They don't need to get the torch shining. The just pointing it at the overhead lights in the room is sufficient for a high reading. So if they then have the buzzer, they are going to use a digital write. And if you set a particular pin to, so if they put the buzzer onto P1, again with the red and the black on the 3 volts and ground, if they write 1 to P1 with the buzzer attached to P1, that will buzz. Hurrah! So we can drop that in there. However, we then have the unedifying prospect that once it's turned on, it never gets turned off anywhere. So if at this stage a student hasn't got to a point where they've added either the else or the else if in, it then becomes actually quite useful if they do add it, so that we can turn the buzzer off. So it's only turned on when it is high. Yeah, resetting the buzzer sort of quite important. So the next step is to get this to run all the time, and this is where we get the forever loop. And my preference is actually to duplicate the whole lot, so they've got that to refer to, and then we can pull that into there. However, this is going to whip round so fast that it's going to sort of just squeak or not squeak left, right and centre, so it is rather a good idea to drop say a 10-second delay in. It's in milliseconds, so that's a 1 second delay, that's a 10-second delay. A good talking point: how many milliseconds are there in a second? Now, for those, again, who are a little bit more switched on or ahead of the game, they could, in fact, actually sort of delay the buzzer so that you have a certain degree of time available. Not recommended under World Health Organization regulations. Sounds a bit prissy of me to suggest this, but some of my work is in the health industry, and 17 out of 100,000 people get skin cancer each year, and that's if we don't want to be encouraging the wrong messages. So enough for the party political broadcast. Let's set a count so that we can say, have we checked enough that we now feel that it's time that we should do the buzzer. We always initialize variables when we're programming, because uninitialized variables are the path to Gomorrah, or is it Sodom? I'm not sure which. So we've got our if, and what we want to do is every time we see the light reading is on the high side, we want to increase our variable, which is called count, by 1, and then and only then do we want to sound the buzzer, which is a logic. So we're going to say if and then we need to go back to logic and say if variables count is greater than, I don't know, we've got 10 seconds, let's say 6, use the right keypad again, 6, then we will turn the buzzer on. Now you'll see here that it gets a little bit sort of silly, dragging and dropping things around the place, but there we go, we are into the right place. So if we've now exceeded the 60 seconds of bright light, the buzzer will sound. Now what would be even cooler would be that they get to a point where it actually beeps when there's a problem and then sounds the buzzer continuously. Now before I do that, I will just make the observation that whilst testing these things, it is 100% better if you shorten your time range so that you don't actually have to either wait 6 lots of 10 seconds, and in that respect it's probably easier to go for say 2, or possibly change the number of seconds to say, he says, 5. So that would actually be 2 lots of 5 seconds. So it's going to kick in a little bit quicker. So what we can do actually is we could rearrange this for, again, the super advanced students, or if the students are all are in the groove and getting to grips with this, the possibility that actually what we do is we turn the buzzer on, and then we pause for a short interval, and if we have not exceeded our count, what we will do is we will then turn the buzzer off, like so. So what happens is every time it's high, it turns the buzzer on, waits a tenth of a second, and then if the count is not been, if we're less than 2, then we turn it off. And as a consequence, what is going to happen is that it's just going to buzz for a tenth of a second, and then after 10 seconds, because we've got both 2 and 5 there, but until once the count is exceeded, it won't activate this line here, and therefore will buzz continuously until the light reading drops below the high level. You'll see in my notes that I've actually put it actually like yeah, just bear with me. Like so, you end up with exactly the same effect, because it still waits a tenth of a second before turning it off and turning on. It's just a side effect of the way that program flow doesn't sometimes make much difference to how these things fall out. There is actually a technical engineering issue with the way that I had it a moment ago, in so much as it would always wait 5.1 seconds under certain circumstances, and I've just flipped them round. Anyway, don't worry about that. So that is the ultra fast version of how to code up a light monitoring alarm. The LDRs don't read UVA or UVB correctly, but on the other hand, the sensors are about 5p each, unlike the £4 for the UVA calibrated sensors. Just change that, light alarm demo, and we're done.